Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and Steelscape. My name is Stacy Ranella and I'm the Editor-in-Chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox. Don't forget to check your spam or junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Michelle Vondran. Michelle is the Manager of Product Innovation and Technology for NS BlueScope Coated Products, North America. Michelle graduated from California Polytechnic State University, San Luis Obispo, with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, later BASF, coil coatings with a focus on polymers. This position also included lab development as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roof Rating Council and Energy Star Roofing Program. She initially joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. She has held several positions, including Quality Systems Manager, Technical Manager, and now the Product Innovation and Technology position. She oversees product and process development, product performance criteria, and warranties for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. Michelle is an active member of the National Coil Coaters Association, sitting on the technical committee, as well as the Zinc Aluminum Coaters Association. In this webinar, Michelle will discuss strategies for success when designing with zinc-coated metal. Welcome, Michelle. We appreciate you joining us today. Please take it away.
Thank you, Stacy. That introduction is always more impressive than I think the realities. Thank you for that. Welcome, everyone. Yes, we're going to talk about aluminum zinc coated steel metal roofs today. Here's the presentation overview and administrative stuff you need to know. We've got 4 sections. We're going to talk about what is aluminum zinc metallic coated steel and why we use it. And then we'll look at kind of the more common roof types that we see done with this product. We'll talk about longevity and how to design for the best performance and to get the best out of this material. And then, some specialty items, what to do, what not to do, and how to maintain, and how to design and plan for maybe some special circumstances with this. So what is an aluminum zinc metallic coated steel roof? It's exactly what it sounds like. It's a mixture of aluminum zinc applied to base steel. This product's been developed to have superior corrosion resistance out in the field. Can come in a lot of forms. It gets used bare, gets used painted, can form it into all kinds of shapes and pieces and parts, stamped, roll formed, cut. So we're going to cover all of that today. So first question, what is the purpose of a metallic coating over steel? It's to provide corrosion resistance. I think we all know that steel in and of itself rusts really bad and very quickly. Not a great material to use for architectural design projects. So we got to put something on that steel to give it some longevity and the type of performance we're looking for. So a layer of straight zinc, which would be hot dip galvanized steel, or a mixture of aluminum and zinc together do this very, very well. It's, the corrosion is an electrochemical process. Once that steel is exposed underneath, you're going to get red rust. So not only are you losing steel, but you're also got this unsightly red stain that bleeds through paint or onto the bare product. This metallic coating is done prior to painting. It's done in a continuous fashion as we're annealing the steel. Zinc and aluminum is a active and a barrier coating. So the aluminum portion acts as a barrier to corrosion, while the zinc is a sacrificial coating that's going to sacrifice itself to protect the steel. So those two things together in the right ratio give you an incredibly long performance on corrosion. We're talking like 30, 40, 50 years of corrosion protection out in the field. This is a mock-up here of a cross-section of a coated steel product. The yellow would represent the metallic coating layer. It's on both sides of the steel, and then this would be a painted product. We would put primer and top coat, maybe a clear coat. These ratios are actually not correct. Each of these layers is about the same thickness. It's very, very thin. Each layer is thinner than paper when it's finalized. At first, I want to talk a little bit how we make this product so you can understand the manufacturing process and how it gets to market. We start with giant rolls of steel. Imagine giant rolls of toilet paper being handled and processed that weigh, 40 to 60,000 pounds of base steel. We put that through a continuous coating line, or a metallic coating line as we refer to it, to get this metallic coating applied. Then it would go on to the paint line if it's going to be painted. We'd get still in rolled form, would get transferred then to a panel manufacturer or a shingle or shake manufacturer who would make their product out of that coil. This is a very generic schematic of one of these metallic coating lines. They are very, very large, often 7, 8, 9 stories tall. They are very long. They hold anywhere from 2,500 to 5,000 linear feet of steel from end to end. They run at 150 up to 600 feet per minute, depending on your line and how old it is and how it's configured. So very, very fast, very efficient. There's more going on here than just applying this metallic coating though. So we're also determining the grade of steel and what its mechanical properties, structural properties are going to be. So we load 2 coils at the entry on the left, goes through an accumulator tower. These towers allow us to take up slack and let slack down in the steel so that we can continue running while we stop one end of the line and weld the next coil to it so we don't ever stop. And these lines can run continuously for 30 to 60 days without having to come down for maintenance 24/7. That's what they're built to do. For the aluminum zinc product, cleaning that surface of that steel is really, really important. So we go through a cleaning section. That's an alkaline, kind of soapy solution that cleans that surface off. Then it goes through the annealing furnace, which does 2 things. It's burning off any residuals, oxidation or debris that's on that surface. We're also heating the steel back up to recrystallize it to get the properties that we need. Grade 80, grade 50, CSA. Does it need to be hard and inflexible, or does it need to be really soft and ductile? That happens here. Comes out of the furnace through the snout into the molten metal pot. So this is a giant pot that's got zinc and aluminum ingots that have been melted into it in the right ratio for that coating to stick to the steel. So the steel strip moves through that bath and comes up out through the surface. We have a set of air knives there. Those air knives, high-speed jet air that's being impinged on the surface, controls how much of this metallic coating weight we put on there. We'll talk a little bit later about coating thickness and weights and why you measure that. We cool that strip down, goes through a skin pass mill. That kind of just makes a very nice smooth surface. At a microscopic level, if you were to look at this product, it looks like little hills and valleys until you skin pass it, get that nice and flat. Tension level it to get flat shape, and then wrap it up at the other end so it can go on to its next step. So there's a lot happening in these lines besides just the metallic coating portion that all have to work together at 400, 500 feet a minute. This is what the inside of the furnace, Steelscape's furnaces look like anyways. They're not all the same. We use direct fire furnace. So we're actually impinging flame, open flame on the strip in the first part of the furnace. Then it goes through a set of electric heated and cooled rollers to anneal the product. We have to cool that strip down before it hits the pot of molten metal. That's really critical. So the temperature of the strip and the temperature of the molten metal has to be just right, or you don't get this formation of this metallic coating onto the steel. Here's some pictures. Left to right is inbound material being staged. That's what the raw steel, cold rolled steel looks like before it gets this metallic coating on it, kind of that gray color. Second picture is the accumulator towers. Ours are about 8 stories high. So we can, this moves up and down. So we're changing how much length of steel is in the line, and thus our speed that we're running. The third picture here, and the pictures don't do it justice. I tell y'all, if you get a chance to tour one of these lines, do it. It's pretty impressive in person. So the pot's at the bottom, the strip is coming up. That's the shiny mirror-like portion you see there in the middle. So that's got its metallic coating now on it. It's still hot, hasn't solidified and cooled yet. The air knives are this bar kind of in the middle there. So that's controlling the coating weight. And then the cooling section is up above it. It will run up to the ceiling about 8 stories to cool down, then come back down the other side. On the right is inspection. Obviously, quality is very, very important. We do a lot of different inspection, not only aesthetically, how does the surface look, but then we also test the coating weight, the mechanical properties of the steel to make sure it meets the standards that we're producing to. So I talked about that there's 2 kinds of coated steel. So on the left here, we have hot dip galvanized. This is 100% zinc metallic coating. On the right is this aluminum zinc product we're focusing on today. It's known in the industry as Galvalume or ZINCALUME. Those are trademarked names. This is a licensed technology. We'll talk about the history of that a little bit. The aluminum zinc composition is 55% aluminum, 43% zinc, 1.5% silicone. This is by weight. So by weight, and aluminum has, very low density. So there's a lot of aluminum in this final product, which is why it performs so well for corrosion protection. This is a scanning electron microscope cross-section view of actual product. So on the left, you can see there's just that solid layer of zinc there over the steel and galvanized. On the right, the gray areas here are the aluminum, and the white areas, to me, it always looks like brain matter. The white areas are the zinc. So you can see that there's much more by volume aluminum here than there is zinc. Zinc is a sacrificial product. It's going to eventually corrode and wear off to protect the steel. But then you're left with all this aluminum there that acts as a barrier coating, which is why it's superior to galvanized in most conditions. Because once those little tunnels are there of zinc are gone, you still have all this aluminum protecting the steel underneath. So again, combination, the silicone, by the way, the 1.5% that's in there doesn't do a whole lot in the finished product. That is in the pot mixture for wetting properties and for thermal dynamics in the pot. Doesn't really bring much to the table in the finished product. So we kind of don't talk about it a whole lot. Again, zinc is the sacrificial part. This is galvanic protection for corrosion. The aluminum forms an oxide protective layer known as passivation or a barrier coat. And then that's why this product is going to last longer than galvanized. Again, the zinc-rich areas corrode preferentially, leaving all that aluminum behind that not only is still protecting the steel, but if it's a painted product, you still have enough surface there for the paint to adhere to. Right? If it's just zinc and that zinc wears off, the paint no longer has anything to stick to, and then you get paint bubbling and peeling off. The process for these two, for galvanized and aluminum zinc coated steel, is the same. It's the exact same kind of lines, very subtle differences. A lot of steel suppliers can actually produce both types of product off of one line. They have what we call as a dual pot. They'll have 2 of these pots instead of 1, and they can switch the strip back and forth between them. We happen to have single pots. So the history of this product, it's been around a really long time now. It's coming up on its 52nd birthday, as are some others of us on the call. First sold as Galvalume under the Galvalume name by Bethlehem Steel in June of 1972. They decided to license this product to other steel companies rather than keep it proprietary. So you have to obtain a license to make this product. To call it Galvalume, you have to be licensed. There are some producers like us. We call ours ZINCALUME. Others have come up with their own trade names. You can't be licensed unless your facilities are reviewed. They help you with commissioning, help you with technical problems. It's kind of a unique community. We get together on a regular basis and kind of compare notes and talk about product and challenges and how we're operating. There are licensee holders in 28 countries now. In the United States, there are 8 companies that hold licenses to make this product. There are unlicensed aluminum zinc products being sold, especially out of Asia. We stress it. If it's not licensed, proceed with caution. Its quality, consistency is probably not as good as those of us that are licensed. So just if they're calling it generic aluminum zinc and don't have a trade name associated with it, that's kind of your first clue that it's probably not licensed product. So now we have roofs that are 50 plus years old, right? The initial ones that went out there. The ZAC Association, which is the Zinc Aluminum Coaters Association, all of us license holders, we have a program where we're going out and checking these long-term roofs every 5 to 10 years to monitor their performance and see how they're doing. What we're finding is that the ZINCALUME or Galvalume panels themselves are outlasting the other components on the building because their life is so good. Got about 30 billion square feet of product out there at the moment. Probably this was done a couple of years ago, so it's probably quite a bit greater than that now. But it will outlast traditional galvanized product by about 9 times in most conditions. So again, why do we want to use this product? Well, the superior corrosion resistance, so it's going to last way longer than anything else. You can actually get a warranty for corrosion on this product, which you cannot do on galvanized. Warranties are out there now up to 60 years on the substrate for corrosion performance. They vary from 40 to 60, 60 being the longest. Kind of depends on coating weight, whether it's painted, how close to the ocean you are, those kind of things. There's a benefit to all this aluminum. So you get more linear footage per pound out of this product too. So it goes a little bit further than galvanized does economically. Can be formed into all kinds of different stuff, very versatile, and looks really good bare. This is actually a bare application here in this picture, an unpainted roof, and it's a really nice look. It has a very small, tight spangle crystal formation, very uniform, very pleasant color to it. So there's just some comparisons in different conditions. So rural, industrial, and then moderate marine and severe marine. This is years to 5% red rust. So how long is it taking for that metallic coating to wear away, be sacrificed to get down to the base steel? See that we're 30 plus, even in moderate marine, and in severe marine, and this is unpainted, you can get to at least 15 years or longer before rust is a problem. So it's a really good product for marine locations, especially if you combine it with a marine paint system on top of it. So a little bit kind of to illustrate what's happening and why its corrosion is so good. And I need to like use AI maybe to come up with some better graphics than this at some point. But on the left, traditional galvanized, base steel, zinc layer, paint on top. If you scratch through that paint, which happens over time or during installation, and that zinc coating is exposed, it's going to start weathering away. Now that's going to take a few years. It doesn't happen instantaneously, but once that zinc coating is gone, you're now down to base steel. You're going to have red rust. That zinc corrosion is going to accelerate. The paint's not going to have anything to stick to. Now you've got this kind of big unsightly spot. On the aluminum zinc product, again, you have this mix of the zinc and aluminum. So even when the zinc, the yellow in this graphic, is gone, it's completely consumed, you have all this aluminum left that acts as a barrier coating. So you still have protection there. You still have something for the paint to adhere to, and the steel's not exposed. And again, it can be up to 4 times slower rate of corrosion than galvanized. Cut edge, same phenomenon on cut edge. So if you have a cut edge in an installation on galvanized, that zinc gets worn away. Now you have this flap of paint hanging out there that's got nothing to stick to. That peels back, exposing more zinc, more steel gets exposed, and kind of just becomes this vicious cycle that accelerates. On the aluminum zinc product, you're not going to have that. You're still going to have aluminum on the edge. Now, the aluminum zinc product, the Galvalume product, is going to corrode eventually, but just at a much slower rate. And here's an example, right? Pictures are great. So this is The pictures on the right here are an aluminum zinc painted product, a galvanized painted product, painted with the exact same paint, put out at the same time of exposure. And you can see that this is after like 5 or 6 years or 2 years. You can see that there's red rust. We call this edge creep on the galvanized. The top picture, the aluminum zinc product, yeah, there's some corrosion going on there. You can see that the edge has gotten a little rough and discolored, but you're not down to red rust and you're not losing paint off of it. The graph there just shows you that most of the corrosion on this product occurs in the first couple years, and then it just kind of stops and plateaus and really doesn't change after that. So kind of what you have after the first maybe 2 to 5 years is kind of how it's going to be. It gets very stable. Now, why 55% aluminum, right? So trust me, some very, very smart people at Bethlehem worked for many years getting this ratio just right. And the graphs on the right there kind of show you that, at a lower aluminum content, performance, time to rust, not so good. As soon as you get kind of in that 45 to 55% range, you get this huge jump up in performance and resistance to corrosion. So that's how they landed on 55% aluminum, 45% zinc. The ASTM specification for this product is A792. You will see that called out in specs. Coating weight. So we can put different amounts of this metallic coating on the steel. AZ55, AZ50, and AZ35 are the three most common here in the United States. This is a weight. So AZ55 is, 0.55 ounces per square foot. It's about 0.0018 inches total, but that's split between the both sides of steel. AZ50 at this point is probably the most common coating weight we see called out in the specs and the most common that's getting used for painted product. Still see AZ55 being used for bare applications because you just want a little bit more protection on there. If it's AZ35, which is a very, very low coating weight, there is no warranty, and you actually cannot use the Galvalume name or the ZINCALUME trade name for that product because it's unwarranted. But that low coating weight has a place, not for exterior necessarily, but we do see it getting used for interior applications. We see it getting used for appliances, interior electronic housing and casings. So it's good for that. Some low-end rainwater goods too uses AZ35 because they don't need the warranty. This is kind of demonstrates why this AZ35, the lower coating weight, is not so good. And again, this is a cross-section scanning electron microscope picture of this product. The AZ35, the gray tubes here, just a little hard to see, are the zinc portion. The white fluffy part's the aluminum. You can see at AZ35 at a lower coating weight, some of these zinc tunnels or zinc paths go all the way down to the bare steel underneath. So when those corrode away, you're going to have an opening there to the steel. So corrosion protection is not going to be great. On an AZ50 or higher product, you can see that the gray areas, the zinc-rich gray areas, very few of those actually make it down to the surface of the steel. And you got a lot more aluminum surrounding it to protect it. So that's why we like to stay at the higher coating weights. Some other attributes of this product: it has a really high SRI, solar reflectance index value, up around 64, 65. So that's pretty good. It does qualify for a lot of cool roof specifications and desires out there. Readily painted. I mean, this is really where it shines. It's a great surface to paint. Very smooth, nice, consistent surface for factory coil-coated paint application. And most of the product getting produced is used as a painted product. So if you combine a really high-end paint system with this substrate underneath, it's kind of the Cadillac of metal panels that are available. Temp range, it can withstand a lot of temperature fluctuations. So constant temperature of 600 F without discoloring that surface, and up to 1250 sustained temperature without any oxidation occurring. Can be field painting though. If you want to use it bare, and folks do buy it for this and then field paint it, it can be powder coated, it can be field painted with liquid paint readily. It takes that well, so it does get used for that. Weldability, it is weldable, but certainly not recommended for the painted products because you're going to burn that paint and scar it when you try to weld them. So green building, LEED. Many of you, I'm sure, are much more familiar with LEED than I am. But yeah, we can use this product to meet the heat island reduction portion with the SRIs on steep slope above 39, not a problem. Material ingredients reporting. There are quite a few producers of this product that have HPDs or EPDs on the bare form of this product. Living Building Challenge. Most aluminum zinc product being produced does qualify as red list free and can obtain that label if desired. Okay, so I've sung its praises, but we do have to talk about, there's a few scenarios where this product is maybe not the best choice. So in all fairness, we're going to cover that. So where is it suitable? Almost all residential coastal applications, you're going to use this. Extreme weather environments, absolutely. Industrial and commercial settings, yep, check. Curved, tapered roof applications, yes. Retrofit applications, yes. Where is it not great? High alkaline environments, especially in contact with wet cement, is really problematic because of what it does to the aluminum portion of that metallic coating. So can use it with cement and concrete, but you got to have a barrier between it so it's not in direct contact. Animal confinement's a big one. This product is not suitable for animal confinement. You need to use good old traditional galvanized. A lot of disclaimers out there around animal confinement and aluminum zinc product. And it's the urea in the animal waste products and the aluminum that don't get along and corrodes really fast. Low slope, but low slope is an issue for any metal product, not just this product. Anything below 1/4 and 12, where you're going to have standing pooling water, you're going to have corrosion issues. Doesn't matter what you've used. Contact with dissimilar metals, and we're going to talk about that a little bit more in the presentation. Again, that applies to galvanized and the Galvalume product both. And then this product specifically doesn't do well buried in soil for culverts or building edges, fencing or piping. It doesn't like that environment, so we don't use it for it. Okay, I'm going to stop here, take our first round of questions real quick.
Okay, thank you, Michelle. We have some questions coming in. And quickly, if we can't get to all the questions, Michelle's contact information will be on the screen at the end of the presentation, so you can always get in touch after. And also, everyone who registered will be receiving a link to the presentation within about a week. First question, Michelle.
Yep.
Once the zinc has all been sacrificed, does the aluminum degrade in any way?
Yeah, there is some very slow oxidation that occurs over time of the aluminum, but it's at a really slow rate. Like I said, after the first few years, it becomes a very kind of stable scenario with the aluminum that's left there. But you will, I mean, you know, buildings that are 56 years old don't look as good as they did when they were 10, but they're still holding up quite well. And you're not down to red rust. You're not down to base steel. But yes, you are continuing to lose a little bit of that aluminum over time.
How does Galvalume compare with galvanized zinc with respect to site bending or break shaping? Do either tend to split on the surface when painted?
They're very comparable for the most part. The aluminum zinc product at heavier gauges under extreme tension bends, you will get some fracturing and cracking of that metallic coating versus galvanized. And everyone's warranties and technical bulletins explain that in more detail. But it's rare that there's much difference. But yeah, the splitting of the metallic coating surface is pretty rare. They're, kind of would think there'd be something wrong. We do see splitting like on a grade 80 full hard steel product that's not very ductile. You'll get fracturing, but it's actually the base steel underneath that's fracturing, not the metallic coating per se.
Okay, let's do one more. If panels are scratched during installation, how much does that affect the longevity of the panels?
Yeah, kind of a loaded question. Depends. If it's not through the metallic coating to the base steel, you're pretty good. It's probably not going to be an issue. If you're down to base steel, then obviously you've got an opening there and the steel's exposed, and that's problematic. But as thin as this metallic coating is, it takes quite a bit to scratch it down to the base steel. Like you got to be abusing it pretty hard for that to happen. But light scratches that aren't all the way through, usually not an issue.
Okay, let's get back to your presentation, Michelle.
Okay, now we're going to talk about roof types and advantages and disadvantages of those. So our question here, what are the two most common types of metal roofs used with this substrate? Exposed fastened and concealed fastened. Makes it easy, just the two. Now there's a lot of categories within these. We're going to touch on the most popular ones. So overview, right? This product is readily available. I just told you all there's 8 producers alone here in the United States who are selling to all kinds of end users making roof and wall panels. So getting it's not a problem. But, the types of panels available, varies widely. So concealed or exposed fasten, and there's pros and cons of both of those. Concealed fasten, just what it sounds like. This is going to be your standing seam architectural type panels that snap or seam together, and there's no exposed fastener that can be seen from the outside. And maybe some batten types where you're covering that fastener. Exposed fastener is your corrugated type products, trapezoidal box rib type products, where you're actually putting a fastener right through the panel into the roof, and you can see that from the outside of the building. Metal tiles and shingles. I got those kind of in italics down here because they can fall into either category depending on how they've been made. So, concealed fastener. Snap seam, non-clip version there on the right. So you've got your male and female leg. You're attaching through the flange on the right there into your substrate of your roof, and then you're snapping another panel over the top of that to hide that fastener. This does not allow necessarily for thermal movement, give and take that happens. So that's a limitation. However, you can also use a floating clip or clip system as well to give you a little bit more movement there. So there's just we see this application, this type of panel a lot for residential, light agricultural. It's good performance, relatively easy to install. You don't need any kind of special equipment or expertise. See it a lot with styrations, which removes some buckling and oil canning that's inherent in light gauge steel products. And you can, like I said, you can get clip versions. If you have long spans or need some greater performance criteria, like for wind uplift or structural purposes, you can get clip versions of attachments that provide that. So the other more common concealed fastener that we see, especially for commercial architectural projects, is standing seam or mechanical seam, right? So this is going to give you superior weather tightness, great structural performance. These products typically have very high wind uplift ratings, maybe even really good hail impact ratings as well. This is what we would use for low slope applications. It is a more expensive product. It is more labor intensive to install. You got to have a level of expertise. It's a step up from what we just covered. You may have to have mechanical seamers on site. So you snap these panels together, and then you're actually running a device along that to fold it over and interlock it together, which is where you get your weather tightness from. Can apply this over open framing because of the structural properties it has. You're always going to use a floating clip here because of the thermal movement. And the number of clips is going to be dependent on how long a spans you're doing and what the specific roof profile looks like. So there's also batten styles or T styles. So, you use a clip, kind of lock the panels together, which would be exposed, but then you come in with this batten or this cover to snap over that so it's hidden. So kind of gives you a standing seam kind of look, but a little bit easier to install, a little bit less complicated. A lot of design flexibility, though. You can do curved and tapered conical shapes with this as well. You may need some gaskets or sealants for weather tightness, depending on the specific profile you're using. And then the T panel at the bottom is just 2 panels intersecting to form a T. Got the description there. And then you snap a batten over the top of that to hide it. Exposed fastened. This is old traditional kind of panels, right? I think a lot of us, you think about like a tin roof, an old galvanized corrugated roof. This is what people think of. So We see a lot of R panel, U panels here. Kind of got these higher ridges and striations in between. See this a lot on ag and residential. It's got maximum strength. Great, easy to install, goes down quickly. Have a couple places where you're fastening. You might put some mastic or sealant in there to give you some weather tightness properties as well. 5V crimp style. This looks a lot more like standing seam from a distance. So, right, from a ways off, you might think it's a traditional hidden standing seam type roof, but it's actually not. It's actually an exposed fastener going through the overlap of those panels. Doesn't quite have the same performance qualities as a standing seam roof at the end of the day. Here's our corrugated. We've seen a resurgence, popularity of this product of the last 10 years, kind of as the farmhouse look and movement took off. See it using a lot now for wall too, and for like wainscoting on interiors and those kind of details. It looks great, but it is an exposed fastened product. You're going right through the panel. You can see it from the outside. Curved edges are nice though, reduces harshness of shadows. Blends well with other traditional features. And then at the bottom, we have trapezoid or box rib, as we call it a lot. So that's a more distinct kind of square shape or a V shape. Seen this a lot in modern design the last 10, 15 years, and seen it used right vertical or horizontal, both of these profiles. So you can get some interesting designs by turning it, using it in different ways. So the box rib, the trapezoidal, is probably better for larger surfaces. Get nice coverage on it. Metal tile and shingles. Again, these can kind of be exposed, fastened, or concealed depending on how they've made the panel. Some of these are stamped, some are roll formed. But, you know, from a distance, if done in the right paint system, it's really hard to tell that this isn't real tile or shake or shingle. It can look really, really good. It is very cost effective. It's got decent structural performance. It can be a challenge to create the flashing and trims for these panels. I hear that complaint in the field. Some of these are coated with actual like granulars and rocks. Some of you might be familiar with like the Decra stone coated roofing product. That is an aluminum-zinc Galvalume product underneath that gets that coating on it. Really good hail impact resistance. Costly, not as economical as traditional metal panels are. So again, cheat sheet real quick, exposed versus concealed. Exposed fastener is going to be cheaper to manufacture, ship, and install. Don't need a high level of expertise to install it. It's pretty straightforward. Wide variety of patterns though, and panel profiles and colors. The panels are pinned at the attachment points, right? So that thermal movement over time can stretch those holes that could be problematic for water ingress later. Gotta look for that. Can't use it for low slope or really long lengths because of the weather tightness issues. Might need some sealant or mastic in there. Can be curved, that's fun, and can go over open framing. Concealed standing seam roofing looks great, nice clean look for large flat areas, no visible fasteners, superior weather tightness. Going to have be able to have a lot of thermal movement because of those floating clips. It's not going to be a problem. These kind of panels can also be formed on site. There are portable roll formers that can, you know, if you're doing really long lengths that you can't put on a truck and ship, or curved or tapered profiles, that's usually done at the job site. And can be suitable for low slope applications. I know we did a project, we did part of the LAX international terminals when they redid those. It was actually aluminum, but they were roll forming 60-foot to 80-foot panels at one time on the roof and installing it right as it came off the roll former. It was kind of impressive to watch. Came out looking great. Specification considerations, right? There's a lot of different panels out there, panel manufacturers. Your rib height, right? That's going to impact shadows that are cast, how it's going to seem, the panel width. That's going to impact speed of install and the aesthetic look. May have some performance attributes that vary by panel width as well. Attachments, how many attachments do you need versus the panel size? Environmental factors, right? Snow loads, ice loads, make sure that that's under consideration if you work in areas where that's a concern. Accessories. Well, what are you going to attach to this roof? Solar panels go over metal roofing really, really well, but you got to make sure that the distance between the ribs is conducive to that, any walkways, that's all been taken into consideration. Avoiding oil canning. Like I said, oil canning is inherent in light gauge steel product. You kind of get that buckler wave. We do a lot to try to minimize it, but sometimes it's just there. You probably want to go to a thicker steel, a different gauge, a heavier gauge of steel, and then also maybe put some striation. So you don't have just an open flat surface that's going to show that. You want to put some little pencil ribs, little lines in there to break it up. Paint systems. There's a whole other presentation on that. Polyesters, S&P, PVDF's the most common. High-end panels are mostly going to be PVDF for commercial application. And then just be aware of manufacturer compliance, right? Good panel manufacturers should have a whole host of third-party certifications around wind uplift, hail resistance, fire ratings, those kind of things. Usually UL or FM, IATMO, there's a bunch of them out there. Okay, quick break for a couple questions.
Okay, next question. Do you agree that cut edges should be smoothed and touched up?
Yeah, we're going to talk about cut edges. Yes, if possible. First of all, you got to cut them right. And there's a whole lot of technical bulletins and guidelines out there from everyone making Galvalume as to the best way to do that. And then how you install it. But yes, if there's an opportunity to hide it or to seal it or to coat it, yes. The caveat to that is that any kind of field applied coating is not going to hold up as well as the factory applied coating. But there are clear coats out there you can seal edges with. But again, this product has really good edge corrosion performance. We don't really worry about it too much, those cut edges, unless you're near the ocean, which at point you should not be using a panel with exposed cut edges. It needs to be a hemmed edge, ideally.
What is the best system for hurricane-prone areas?
A mechanically seamed standing seam roof. Yeah, probably in a heavier gauge. Of course, your understructure is really important. And I'm not a structural engineer. I'm not an installer, but there's some panels out there. The one I know is MR24. Yeah, that are heavily mechanically seamed in place and have incredible wind uplift. And I know those get used a lot in the hurricane prone areas. So yeah, be my recommendation.
Okay, let's do one more question. Does the aluminum in the aluminum zinc hot dip coating act as a radiant bearer on a roof application to reflect IR, or is this the same property as having a high SRI value?
So it's the same. So the solar reflectivity of this product is high, largely in part because of the aluminum, right? That aluminum is a very reflective surface and reflects back a lot of that solar radiation, more so than just straight zinc and galvanized. So the SRI value for aluminum zinc is a bit higher than straight galvanized because of that aluminum component. Very shiny, very reflective. Yep.
Okay, we'll take some more questions at the end of the presentation, but back to you, Michelle.
Okay. Our next question, does slope of the roof matter when selecting an aluminum zinc roof product? Absolutely, but I will say that this applies to galvanized as well. Yes, it'll decide whether you're going to do exposed fastener or concealed. The height of the ribs matter. The span in between the ribs matter when you get into low slope. So minimum pitch is definitely going to affect life expectancy. We prefer not to go lower than 1/4 and 12, which is pretty flat. But anything less than that, your warranty's off the table, not going to be covered. So with a low pitch, low slope, you want to go with a deeper pan that's going to allow for better water shedding. We want that water when it gets on there to run off well. Concealed fastener profiles are going to be very effective for that, and you're not going to have holes or openings where water can breach the roof and get underneath. And you can't actually get rust from the inside out if water's trapped underneath these panels. So want to go with concealed fastener if it's low pitch. And then, of course, sustained exposure to ponding or standing water is going to expedite corrosion on no matter what product you're using. And we have a picture here. This is a roof that was very low profile. I think it was about half and 12. But the way it was designed, there was water ponding and sitting. And standing water is just never good. At the very least, you're going to get some kind of biological growth over time that's going to degrade the surface of these panels as well, if not just outright corrosion on the product. Again, we talked a little bit earlier about walkways, solar panels, and other accessories. You can use them, still get your warranty, but you need, especially with solar panels, you want to make sure that no dirt and debris is collecting underneath. You want that to shed off. You want to make sure that it's not dammed up or blocked somewhere. You got to also be a little careful about any drainage lines and copper in direct contact with this product. So as long as you're avoiding that, you're good. Airflow, you want good airflow that helps prevent corrosion, but if solar panels need good airflow anyways to work right, so they're usually offset up off the roof enough that it's not a problem. Again, technical bulletins. All of us that are producing licensed Galvalume have 15 to 20 technical bulletins that cover all of these various topics on our websites if you want to know more. We're going to talk about galvanic corrosion and dissimilar metals in a little bit more detail later, so I'm going to hold off on that. Vents and fume extractors. This product gets used in a lot of commercial applications, industrial applications, where there could be some heavy manufacturing going on, chemical manufacturing going on. You want to make sure that the fallout from any of these is as far away from the surface as possible. Locate them where prevailing winds would blow that fallout clear. You can also put some protection around these as well, either like a membrane type material or stainless steel to help protect the surface as well. But you want to make sure that the height of the flue is high enough up off the panels that it's just not immediately falling down onto the roof. So dissimilar metals, right? So it's around our galvanic corrosion. And it's really not an issue unless you're in a corrosive environment, especially near the ocean. Further away, two items are on this chart on the right, the more problematic they're going to be. In a corrosive environment, you basically set up a battery. And the more active metal, galvanized steel, zinc, aluminum, that's down here at the bottom, is going to sacrifice itself at an accelerated rate to protect anything that's higher up on this chart. So we see stainless fasteners used a lot, and they're a great choice in 90% of the environment they get used in. But if it's a marine type environment or a heavily corrosive environment and you've mixed stainless with this product, the aluminum zinc product is going to sacrifice itself at an accelerated rate to protect the stainless steel. So there's a lot of information out there around proper fastener selection, trims, gutters, what to mix, what not to mix. To avoid early failure. Again, your trims, flashing, gutters should be as close to the same metal, if not the same type of metal, as your panels that you're using. So yeah, aluminum is a good choice, right? But copper and stainless, other metals, we really just don't recommend them because of that potential for galvanic corrosion. And then, of course, gutters and trims, got to make sure you just don't have standing water and be shaped so that you can clear out the bottom on a regular basis. So this is some cautionary tales. This is copper used with painted ZINCALUME, Galvalume products in Hawaii. So the fascia at the top and the bottom is copper with these painted green panels. Now, water flow was correct. You don't want water flow to be from the copper to the ZINCALUME. You want it to be the other way around, which they thought they had done here. So we should be good, right? No. So a few years in, they had this accelerated corrosion occurring along the edge of the bottom roof line only. Went and inspected it. What we found out was that due to prevailing winds and rain patterns, where this is that we were getting rain droplets and stuff falling off of the top copper fascia onto these panels and running down to the edge and sitting, causing premature corrosion. Other design considerations. So aluminum zinc expands and contracts the same as other steel products, galvanized products. But again, you want to use a clip configuration, floating clip, depending on the spans that you're doing and how it's attached. If you're doing exposed fasten and attaching directly to wood or steel purlins, that can relieve some of the thermal movement on smaller panel lengths. And then we've got an example here of kind of the two common types of clips that we see for concealed fastener. A simple design, which is a one-piece clip. That clip is fixed to the substrate underneath. Panel is attached to it with a floating connection, allows the panel to move. But the clip does not move. Dual clip design, you can have two pieces, clip fixed to the panel and base, but has a floating component within that panel. So the clip itself can move as well as the panel in that configuration. Again, wind uplift, we talked about that. Need to make sure you understand what those needs are going to be. Air and water infiltration rates, product loads, snow and ice. You can attach snow guards and ice dams and stuff to these roofs readily. Not a problem, works great. You know, is it coastal? Do you need a special finish because of that? Talk to your supplier. Make sure that you have that conversation up front. No one's definition of proximity to the ocean is the same. Use a 1 mile rule of thumb. If you're installing within 1 mile of breaking surf of the ocean, make sure you've talked to everyone in the supply chain about the best product for that and whether you're going to have warranty or not. And here's my disclaimer, because I'm not an installer or contractor. I know enough to be dangerous. Each panel manufacturer is going to have full installation guidelines and requirements for their product. So we're talking very high level general here. The specifics are going to be different by each manufacturer and panel design. And we're getting close on time. So I'm going to skip questions and go through to the end here. And we'll take some questions at the end. So what can cause premature corrosion on this product? We've talked about how great it is, but when is it not great? And again, wet cement, soil, and dissimilar metals. Wet or chemically treated wood, because not only the moisture content, but chemically treated wood often has copper compounds in it that leach out. It's not great for this product. They don't like each other. They don't play well together. So again, fasteners and penetrations, the insulation, sealants, cuts, terminations, using other materials with it. Field cutting, came up earlier, field cutting, cut edges. Job site cleaning, you got to clean up after yourselves, or there's, you know, you cannot leave shavings and metal fragments behind on this roof because they're going to rust and leave a mark. And then we'll talk about maintenance. So galvanic corrosion, this is a stainless steel fastener that was used on a painted Galvalume roof that's 300 feet off the surf break in Southern California. This complaint always comes in as my paint is bubbling and failing. Well, yeah, your paint's failing because the metal is rusting from the inside out and has nothing to stick to anymore. So yeah, so you can see that around this stainless steel fastener, there's also a stainless steel support member with a stainless steel gutter that's attached. All around these stainless steel fasteners, you have this galvanic corrosion occurring underneath. So the zinc and aluminum are sacrificing themselves at a very accelerated rate to protect the stainless steel fastener. We went back a few years later, you peel the paint back, you can see that we're down to base steel and red rust at that point. Happens very, very quick. This was installed for about 2 years, and this was presenting already. So you got to always check for compatibility, especially in a marine environment. Corrosive environment. This is an example of a fastener that was over driven. So broke through the washer underneath and penetrated and broke that metallic coating underneath on the painted metal. Kind of looks like galvanic corrosion on the surface of it because you're getting this bloom of corrosion underneath the paint. But the root cause is a little bit different from the fastener being used wrong. So again, avoid copper. This is an example of copper dripping, running off onto a bare Galvalume roof. Really bad, kind of black, unsightly corrosion that occurs. Incompatible materials can be painted, right? So it's direct contact. If the stainless steel is coated or painted with something, then it should be okay. The copper, if the copper is painted, so there's not direct contact between the copper and the bare ZINCALUME or Galvalume product, should be okay. Again, got to seal roof penetrations. Make sure you're not getting water up underneath the panels. It'll corrode from the backside out. Use a neutral cure sealant. And install AC units on similar material curbs. So you can do your curbs with the same Galvalume product that the roof panels are made out of. So then you don't have an incompatibility. Edges and terminations. Most roof and wall panels can be made to the exact length they need to be, right? We want to minimize field cutting as much as possible. However, we know that there's transport length limitations. You may have to in-lap depending on the length of panels and what the design of the building looks like. So you want to make sure you do those laps in the right direction, right? So water can't get in between. Use a sealant. Double bead or triple bead tape sealants are common at overlap panel ends and work well. You want to make sure you're waterproof any of the joints and transitions. Insulation. Fiberglass roll insulation is most commonly used, and it's fine, but if that's allowed to get wet some way, and now that wet insulation is sitting up against the back side of these panels, again, you will have accelerated corrosion that occurs from the inside out. Spray-on insulation is also sometimes used under roofs and siding. The only cautionary tale there is make sure it doesn't have a copper-containing fire retardant chemical in it, but there's plenty of products that are suitable. But again, the manufacturer of the panels should have guidelines and bulletins for all of this. Concrete and mortar and the Galvalume product don't like each other. Again, because of the moisture that's in the cement as it's setting up to become concrete, very alkaline, very destructive. It's an example of a wall panel that was just set right on the concrete foundation without any kind of barrier there. And you get this really nasty edge creep that occurs. But if you put a barrier in there, you're fine. Now, if you get splashes of mortar or masonry debris on the surface during construction, they can be wiped off immediately. It's fine. But if you let it sit, could be problematic. Not only could it stain the surface, but it could cause corrosion. And again, we talked about not putting this product in soil. Don't bury it. Cured mortar, not a problem. Only when it's wet. Again, wood, green or unseasoned lumber should not be used. And this applies to galvanized as well, just because of the moisture content in there. It's going to be problematic. Kiln dried timber is what you want. Steel must not be placed in contact with timbers that are going to retain moisture and be wet. And then again, some treatments and fireproofing can have copper compounds in them. So you just need to make sure there's a barrier between. Handling and storage of the job site with metal needs to be well understood. It's why you want to use an installer that really works with metal primarily and knows what they're doing, right? Just carrying the panels, right? If you bend them or flex them wrong, you get a permanent dent or indentation, which is the panels on the bottom here. It's a little hard to see, but you can see they got creased or dented. So not only does it not look good, but you're potentially shortening the lifespan of the product as well. Water might accumulate there, debris might accumulate there. You want to keep this product dry. Panels, when they're in bundled form, when they're nested and stacked together before installation, have very little airflow, but can still get wet in between. If they get wet in between with no airflow, it's called storage corrosion, and it can happen very, very quickly, and you get it's really tiny blistering of the paint that occurs that eventually that paint's just going to come off prematurely. So I want to make sure that it's stored dry. Again, there's a lot of bulletins and directions on how to do that, how to tarp it and keep that moisture out of there. Field cutting. I don't know who asked that earlier, but here we are finally to your slide. Right, we may stop to field cut for valleys, terminations, other roof parts. You want to do it, be protected and hidden as much as possible by other trim parts. The burr, right, needs to be down. The shear cut needs to be from the top of the panel down and installed that way so you don't get moisture hanging on the edge via capillary phenomenon. You want it to be able to roll off and drip off that edge. So bend them down slightly. And then, yeah, in severe marine and industrial environments, yes, the field edges should be protected, covered, painted, sealed somehow. There's a lot of products available for that. Site cleanup. Again, your brickwork, mortar work, can use a light hydrochloric acid solution to clean that off quickly. Should be fine. Best is just not to let it get on there in the first place. Mask off your roof panels. Swarf. This is a big one we see. This is little metal shavings from fasteners or cutting that don't get cleaned off the surface of these panels. Those little particulate items start to corrode and form red rust. This comes in as a complaint to us as, hey, I've got this brand new roof and it's rusting already. No, the panels themselves are not roofing. It's the debris on the surface that's roofing. But what happens is once that red stain is there, really hard to get off, especially off of paint. It leaves an unsightly mark. Panels are going to perform fine, but the roof doesn't look good. So you got to make sure you clean off. Brush it, hose it down, whatever. Get that debris off of there. No cables, electrical conduit, or anything else long term that could create a dam or a catchment area. Get those off of there. Like, if a roof needs touch-up paint, very, very light scratches, you can buy air dry touch-up paints that are matched to whatever you purchased. But they are going to fade at a different rate to the factory applied paint. So they should be used very sparingly and very little. Again, if the scratch is very light and not very deep, you might be better off just leaving it rather than trying to touch it up and making it look worse than it already does. If a panel has a lot of scratches or deep scratches, the recommendation is you replace that panel in its entirety. Right, you got to clean up, you got to do maintenance. It's just like your car, right? You can't not ever wash your car and then complain about how your paint job's looking and how your steel on your car is looking. Got to take care of it. Easy soap solution works well. Metal lends itself well to being cleaned. It's easy to hose it down. It's easy to get up on. This is, they had laid some panels down on this roof and it's low slope to begin with. I don't know why they laid them here, but all this dirt and moisture were trapped underneath and it looks terrible. You get all this debris buildup that needs to get off of there or it's going to be problematic. Okay, I think I'm a minute over. I'm not going to read the summary. I think you guys have all got it. Great corrosion performance, looks fantastic painted, lots of roof profile options. Questions?
Okay, let's do a couple more questions, Michelle. What sealants are typically used or recommended?
The neutral cure, some of the silicone-based ones, I don't have that bulletin in front of me, but there's a lot of them. I mean, and we don't test every one, but yeah, the neutral cure stuff can be used. We've got, again, there's a whole bulletin just on sealants that's available, but really easy to get, very common in the marketplace to obtain.
Okay, bare galvanized rain runoff must be treated before discharge in the Puget Sound area. Is this a concern for the aluminum zinc surfaces?
Yeah, it's a touchy subject. Yes. Well, obviously there's a lot less zinc, right, in this product. We participated in some studies with the state of Washington, and we felt like the runoff wasn't problematic. But it kind of depends on who you ask. I know that certain counties in Washington will only let you use metallic coated roof panels if they're painted, right? They won't let you use them bare. So that's kind of the solution, is just go to a painted product. You're not going to have any zinc runoff, or very, very little. It's kind of a controversial subject. We could probably do a whole hour on. There's a lot of sources of zinc discharge up there in the Puget Sound besides metal roofs that haven't been taken into consideration. But when in doubt, paint it. That's an inert surface. It usually meets all the requirements up there.
When performing a roof inspection where unpainted Galvalume is used, what should the inspector be looking for?
Yeah, any evidence of staining of ponding or standing water, right? Debris buildup anywhere. Check the fasteners. Like I said, we found if it's an exposed fastener situation, especially if they're galvanized fasteners and it's an older installation, they're going to be not holding up as well as the panels themselves. Checking the sealant, if sealant was used, to make sure it's still intact and good. Yeah, make sure it's clean. I mean, that's the big one. Just nothing sitting on the surface for prolonged periods.
Okay, last question. Does a factory paint coating on top of aluminum zinc add significant life expectancy over just factory aluminum zinc coating directly exposed to the weather?
Yes, yes. So the warranties now range, like I said, well, 25 up to 60 years. A lot of people extended their warranties last year. That range of years is based on whether it's bare, resin coated, or painted. So if you're adding a coating like a paint system on it, yes, you get an extension on your warranty because the product's going to last longer because it's coated. So yes. But that
Okay,
said, I would throw out there, I've seen a lot of bare Galvalume roofs that are, 30, 40 years old that look pretty darn good still. I mean, really look good. So, I mean, it's all relative, but yes, paint is going to extend that to some degree.
okay. Thank you, Michelle. Thank you to everyone who joined us today. That's all the time we have. If you need to reach out with any additional questions, Michelle's contact info should be up on the screen.
All right, let's see. There
Just a
it is.
reminder, there we go. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. Once again, it may take up to 5 business days if you are expecting a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folders. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thank you again, Michelle. Thank you, everyone. Have a great day.
Thank you.